Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 9 and in this lesson we'll learn how to read analog voltage using Arduino UNO. That means how to do analog to digital conversion using Arduino UNO. Okay, so we also provide online training and online tuitions, and we also do freelance projects based on MATLAB, Python, embedded system, Raspberry Pi, etc. So if you have any such requirement, then you can contact us at jcbrolabs at gmail.com, or you can visit our website, which is www.jcbrolabs.org. Okay, so let's move forward. So whenever there is a requirement how to or to read analog voltage inside the microcontroller, or there may be many requirement in which a sensor gives data in analog form, we can talk about a LDR, right? So or we can talk about a potentiometer port. So it is a output is not a 0 or 1, right? So it is a continuous voltage signal. So in this case we need to do analog to digital conversion to read that particular data inside the microcontroller. So there are certain basic concepts about ADC. So we'll go through about ADC in a brief, and then we will move forward how to program it. So ADC is which converts let's say analog voltage. Analog voltage means suppose we have 1.5 volt here. So it generates corresponding to a digital code at the output. So digital code, it could be like 01101. Okay, so there is certain digital code. So this digital code is generated with respect to a V reference or some reference voltage, right? So we will not go into the more detail of it, into the deep download. We will cover the upper layer of this ADC. So as we know, continuous voltage is an infinite number of probabilities, right? So while converting a digital code, we take only certain values of it. Let's take an example. Suppose we have a 3-bit ADC. So 3-bit ADC means it can give output from 000 to 111 in this range, right? Because 3-bit ADC can give only these 3 bits of code. So when we are mapping, let's say we want to map 0 to 5 volt between these digital codes. So this 000 will be represented by 0 volt, and this one will be represented by at the maximum value 4.5 volt. So it is obvious to question that obviously there will be certain gap in between. Let's say we go to 000 to 001. So what will be the voltage gap in between these two? Or this is known as the step size of it. So there is a very good concept of it, of the ADC, that is the step size. So step size is like the minimum change in the input voltage to change the 1 bit of the ADC. Okay, so it is generally given by step size equals to V reference divided by 2 to the power n minus 1, where n is the number of bits of digital code which we are going to generate, right? So if we talk about let's say example, we have talked about this 3-bit ADC, right? So and if we are taking a V reference as 5 volt, so this step size will be 5 divided by 7. Right, so we can do a little calculation, and if we divide by 5 divided by 7 equals to 0.714. That means 0.714 volt. That means the next code of this 001, that will be 0.714 volt. And the next code, let's say 010, you added 0.14, so it will be 1.4 something, and it will keep going on. So this particular step size means that means this much of voltage has been lost let's say if we have a 0 volt, and if there is any change, let's say 0.1 volt or 0.2 volt, this ADC will not be able to capture that particular change in the digital code. So this 0.7 voltage has been lost. So this is also known as a resolution or accurate or precision of the ADC as well, this is step size. So generally you find this particular step size in a form like this one, right? So it is here we represent the number or the digital code. Let's say it is the 000, it is 001. We are talking about 3-bit ADC. 010, 011 and 100 and so on. And on this axis we represent the input voltage. So this is the corresponding digital code. So the input voltage could be, this is 0 volt, then it will be 0.714, which we just described, it is 0.714 plus thing, and then this one. So this much of voltage has been lost in the ADC conversion. So it is obvious this particular step size is directly dependent on this n, the number of bits we are going to use. So suppose if this number of bits goes higher, so this step size keeps coming down, and we can get a better resolution in the digital code, right? So this is about the ADC and its resolution and how this step size and the number of bits relates to the digital value. Okay, so in Arduino, when we talk about Arduino, in Arduino we have a 10-bit ADC. So if you go to the data sheet of the controller which we are using it is 10-bit ADC. Some of the AVR microcontroller also have used 12-bit of ADC. Okay, so 10-bit ADC means if V reference, many times V reference could be 3.3 volt or some other things, but most of the times we will be using 5 volt as a reference voltage. So if V reference is 5, then the resolution or the step size will be 5 divided by 1023, and it comes out to be, let's say, 5 divided by 1023, and it is pretty good. It is 0.005, near about 0.005 volt, or we can say 5 millivolt. So we can easily say, like, if there is a 5 millivolt change, or the resolution of this ADC is 5 millivolt, that means if there is a change in the analog voltage within this 5 millivolt, then our ADC will not be able to detect it. So we have to go through the specific of the sensor which we are going to interface with the Arduino, in which range that particular sensor gives the output. If the changes are within the 5 millivolt, then obviously our microcontroller program will not be able to detect it. So at the analog part of it, we need to add some amplifier kind of thing, so that this change comes out in the range of 0 to 5. So that is a different concept when we talk about this amplifier. So that is a part of the analog signal processing. So you must be take care when you are going to a specific sensor to the microcontroller. Okay, so in Arduino there is a very easy to read any analog voltage. Arduino has A0 to A5, that means total 6 channels are there, 6 channel ADC are there. That means we can connect 6 different analog sources to convert, if we want to convert them to ADC. So any specific channel can be connected to any analog voltage source, right? And similarly in Arduino we have a command like analog read, and here is the channel number, let's say A of X, so X could be 0 to 5. So this is the command which directly reads the analog value and gives output into the integer range. So this particular command gives the output in the range of 0 to 1023. Okay, so it gives the digital number symbol in an integer format. Okay, so now many times it may not be well suited to you. Like say if we are using 1.2 volt, so let's say it give output uh, let's say 234. So you may be scratching your hand, okay, what this 234 means. So you need a kind of mapping, like for example, from this 1023 volt you want to convert it back to 1.2 volt directly. Okay, so for that mapping, it is known as the digital to analog voltage conversion. Okay, so it is not the hardware, we are doing it in a software only through the mathematical formula. So this conversion is very easy, or we can say it is known as the mapping. So it is very easy, let's say, right? So here we have the input voltage 0 and maximum is the 1023, and the output we want, because we were using V reference as 5 volt, the 5, right? So we just need to, because it is a linear relationship, so we just need to identify the equation of this line, right? This line equation. So this is V out and this is the input. So it is very easy. The coordinates of these points are 0, 0 and the coordinates of this point are 1, 0, 2, 3, 5. So it is very easy. V out minus 0 equals to y2 minus y1, 5 minus 0 divided by 1, 0, 2, 3 minus 0 into we can say the input code or whatever it is, the number and n. So this will become, V out will be 5 divided by 1023 into whatever it is, we can say number or voltage, anything. So just by using this formula we can convert back the this particular number, we can convert back this particular number into the corresponding voltage. Okay, so this is pretty easy and microcontroller. So now let's say it's all about the ADC and the theory part of it. Now let's move forward towards the how we are going to demonstrate this video in this video. Okay, so we have created a hardware setup. So in hardware, what we have used a potentiometer, or generally known as the pot. So potentiometer is a 3-pin device, and the voltage across this pin or this pin remains constant. Okay, and voltage, not voltage, the resistance between this pin and this pin remains constant. We can say it is 1k ohm or 10k and so on. And when we change this knob either clockwise or the anti-clockwise direction, the resistance between these 2 points, that means middle pin and the outermost pin, keeps on varying. Okay, so if we make a combination circuit like this, if we connect this particular point at plus 5 volt and this particular point as ground, then this V out, so this V out will be 5 into, let's say this one is the R1 resistance and this one is these 2 pins is the R2. So 5 into R2 divided by R1 plus R2. So just by changing this knob, we can vary this voltage, right? So we have connected this particular port to our Arduino, and the connections are very easy. Here's the port. Okay, one point is connected to plus 5 VCC and the another pin is connected to ground, and this particular pin at which we are getting the varied voltage, it is connected to the A0 pin of the Arduino. So this is Arduino. Okay, so now we will write a code to read that particular voltage so that we can check it on the terminal. Also we have applied a multimeter, digital multimeter, which will be checking the voltage available here, and another point is connected to the ground, so that we can verify whatever the voltage we are reading on the multimeter, nearly same voltage we should show in the computer, so that we can verify, okay, whatever our code is correct and how this program is working, that is also correct. Okay, so let's write a code for it and then we'll have a look at the hardware. Okay, so open this one. So let's open Arduino UNO, and here it is. So first task is to create a new file. Close it. Okay, first task is to save it. So let's say on desktop, let's say lesson 9. Let's save it. It is saved. Let's check whether it is connected to, yeah, Arduino is connected. So first of all, we need to decide the pin mode of the pin which we are going to set. So A0, and it should be set to as input. And in order to see the result, we will be sending the read data on the terminal as well. Okay, so let's open the terminal as well. Serial.begin at 9600 baud rate, and we will simply be using int a equals to analog read, so A0, and then we'll putting it back to the serial monitor. Okay, so it is serial dot println, and we want to transmit A over there. Okay, so if we don't provide delay, then we won't be able to visualize the result. So in order to be safe side, let's provide a delay of 1 second or the 2 seconds delay. Yeah. Okay. Now let's compile it and upload it. So I hope it has been uploaded. Now let's see the hardware as well. So this is a multimeter, and let's turn it on. Yes, and this is a potentiometer, and these are leads to connect it to the output voltage potentiometer, and the output of this potentiometer going to the A0 pin. Okay. So let's see the serial monitor. Okay, so you may visualizing we are getting simply numbers there. So if we change it and change the voltage, okay, so you may visualizing a corresponding number is changing there, but we won't be able to identify anything from it as anything from it, because we can get a map like okay, 500 volt relates to this. Okay, but that won't be sufficient, and sometimes this multimeter shows some error kind of thing. Yeah. Okay, now let's change the code so that we can map it, and we can send corresponding value to the serial monitor as well. So let's do some changes, or let's do the mapping, or let's implement this particular formula which we derived here, right? So okay, int b equals to this is multiplied with b0 because this value will be in float. So if we simply write 5 and 10234, the result will be integer only. Okay, so we have to keep that thing in mind. So print and then serial Okay, let's upload it. Okay, it has uploaded. Let's see. Okay, so it is showing 1.98. Actually, it seems like this multimeter is showing some wrong result because we have verified it. Its battery seems to be down. Now it is showing 1.9878. Yeah, so it is nearly same. Actually, this multimeter reading is not accurate right now. So you can say now it is 2.4 volt and it is showing 2.2. Difference is less, and if we make it to 5, now 4.78, no 4.99. Okay, so maximum value it is showing 4.78 while it should be 5 volt. So there is a gap of this 0.2 volt here, and that is because some error in multimeter. Okay, so more or less the concept is clear, like we are getting nearly the same voltage, so this conversion is doing very fine. So you can try it at your end only. So let's say set to some random value, so it is 2.05. yeah, and on the terminal it is saying 2.18. so there is a mismatch of 0.1 volt. That is because generally this mismatch remains 0.02 or 0.0 or less than 0.02 volt. Okay, so or there could be a reason we are providing a power supply from this board only. So it is varying. Okay, that is fine. So this is how we can get the value or the entire value of this or the we can read the analog value into the microcontroller, and this is how we can change that analog value into the corresponding voltage as well on the Arduino, and we can check it. Okay, so I hope you enjoyed this video, and in the upcoming videos we will be dealing with some analog sensors, and then that will be very fun while doing that. Okay, so if you have any doubt and any query or any suggestion, then you can let us know by commenting below this video. Okay, so at the last we also provide online training and online tuitions, and we also help students in doing their technical assignments, and we also do freelance projects based on Arduino, MATLAB, embedded system, LabVIEW, data science, machine learning, etc. So if you have any such requirement, then you can contact us at www.jcbrolabs.org, or you can mail us at jcbrolabs@gmail.com. So that's it for this video. Thank you.